Section 2.0.0 Fasteners and Anchors and Raceway Systems. Explain how to select fasteners and anchors for the installation of raceway systems. So describe how to select and install zip ties, screws, hammer-driven pins and studs, stud-type guns, masonry anchors, hollow wall anchors, and epoxy anchoring systems. And then there will be a performance task. Your instructor is going to want you to identify and select various types of and sizes of raceways, fittings, and fasteners for a given application. Demonstrate how to install the raceway systems and terminate a selected raceway system. Conduit and other types of raceways that carry wiring and cabling must be properly supported. You may have to attach raceways to wood, concrete, or metal. You must use fasteners designed for the use with the specific type of material. Using the wrong fastener or installing the right fastener incorrectly can lead to failure of the raceway support. Project specifications and manufacturer's installation instructions may list the type and size of fasteners to use and how to install them. If not, the electrician must select the right type of fastener. In this section, you'll learn about different types of fasteners, their uses, and their limitations. Uh, 2.1.0 Using zip ties. A zip tie is a one-piece self-locking cable tie used to fasten a bundle of wires and cables together. They're typically made of nylon, may be called cable ties or tie wraps. Zip ties are made in a standard cable strap and clamp and identification configuration. Zip ties can be quickly installed either manually or using a special installation tool. Zip ties that resist ultraviolet light are recommended for outdoor use. Special rated zip ties may also be required for use in return air sealings. That's a plenum, return air. For these instances, consult local requirements. So here's your standard zip tie. Here's your releasable. You can actually push this tab down and you can release it, reuse it. This is a zip tie with an eyelet so that it can be screwed and secured. Then you can still use the zip tie. And here's one with an identification tag. You can print the tag or write it by hand and put it on there. It says, caution, do not over tighten any wrap or cable tie as it may result in electrical interference between the conductor and or damage the cable. Releasable tie wrap version is also available. It's a non-permanent tie used for bundling wires and cables that may require frequent additions or deletions. Cable ties are made in various lengths and colors. Tie wraps can also be attached to a variety of adhesive mounting bases made for that purpose. Always check the job specifications to ensure that you're using the correct cable wrap or tie. 2.2.0 Using bolts and screws. Bolts and screws are made in a variety of shapes and sizes for different fastening jobs. The finish or coating used on a bolt or screw determines whether it's for interior or exterior use, corrosion resistant, etc. Bolts and screws of all types have heads with different shapes and slots. Some have machine threads and are self-drilling. Refer to Table 4 for metric and SAE, or Society of Automotive Engineering sizes of screws and bolts. So here are some standard ones we use. We use 1/4-20. It's a 1/4 inch diameter stud with 20 threads per inch. This is fine. This is coarse and fine. Fine is 28 threads per inch. 5/16 with 18 threads per inch, and if it's a fine thread, it's 24 threads per inch. We're more and more running into metric sizes of screws and bolts, but this whole chart goes over them all. I'm not going to cover them all. Just know that fine means there are more threads per inch than coarse. Size or diameter of the body of the shank is given in gauge numbers ranging from 0 to 24, and in fractions of an inch for screws with diameters larger than a quarter inch. The higher the gauge number, the larger the diameter of the shank. Lengths are measured from the tip of the part of the head flush with the surface when driven. Let's see if they gave us any drawings on that. All right. We'll try to find it later. This is when choosing a fastener for application, you must consider the type and thickness of the materials to be fastened, the size of the fastener, the material it's made of, the shape of its head, and the type of driver. Here we go. Here's good. So they were saying that the length of the screw is measured from the part of the screw that's going to be flush with the surface and the tip of the screw or the bolt. So this type with an protruding head would be measured from the bottom side of the head to the flat of the bolt. And if it was countersunk, let's see, they don't have, okay, these are countersunk. They're meant to actually be depressed, be countersunk into the wood or the surface so that the top of the head is flush with the building material. So you'd measure from the top of the screw to the point, and that would be the length of the screw. Okay. If the bottom of the head is flush with the material, you measure from the bottom of the head to the tip of the screw or bolt, and that's what your measurement is. If they're countersunk, you measure from the top of it, where it's going to be flush with the surface, to the tip. Now, I call these screws because they have a point and they're meant to make their own hole as you push them in. As you screw them in, they'll define a hole. I call this a bolt because it has a flat point to it, a flat tip, and it will not self-thread. It will not make its own hole. You have to thread it with a tap. Use a tap set and tap a hole, and then this bolt will go right in. Or you slip it through something with no threads at all, and you put a quarter 20, or you put a hex nut on the back end of it, maybe with washers. Let's see, using lag screws and shields. So these coarse threaded screws are called lag screws. They're really good for holding because they have a shield, a sleeve. You drill a hole just big enough for this sleeve to go in, and then as you screw the lag screw in, it spreads these two sleeves out and they push on the outside of the hole. It says lag screws or lag bolts are heavy-duty wood screws with square or hexagonal shaped heads that provide greater holding power. Lag screws come in a wide variety of sizes and diameters. They're typically used to fasten heavy equipment to wood, can also be used to fasten equipment to concrete when a lag shield is used. And here's that lag shield. Lag shield's a tube split lengthwise but remains joined at one end. It's placed in a pre-drilled hole in the concrete. When the lag screw is screwed into the lag shield, the shield expands into the hole, firmly securing the lag screw. In hard masonry, short lag shields may be used to minimize drilling time. In soft or weak masonry, longer lag shields should be used to achieve maximum holding strength. Make sure to use the proper length lag screw to achieve the proper expansion. The length of the lag screw should be equal to the thickness of the component you're fastening plus the length of the lag shield. Drill the hole in the masonry to a depth slightly longer than the shield you're using according to the manufacturer's instructions. Okay. Concrete and masonry screws. Concrete or masonry screws, also called self-threading anchors, are used to fasten a device or fixture to concrete, block, or brick. They do not need an anchor. To provide a match tolerance anchoring system, install the screw using specially designed carbide drill bits and installation tools made for use with the screws. So these, I think you're going to call these Tapcons. they tap concrete. So these tap cons will screw into a pre-drilled hole in concrete or masonry, and then they'll tighten up. The installation tool, along with the appropriate drive socket or bit, lets you drive the screw directly into the pre-drilled holes. The holes have a diameter and depth specified by the screw manufacturer. All right, let's move on. I always feel like I'm taking too long on these. Using thread forming and thread cutting screws. These are called self-tapping or self-threading screws. So thread forming screws, commonly called sheet metal screws, are made of hard metal. They form a thread as they are driven into the work. This thread forming action eliminates the need to tap a hole before installing the screw. This one will actually drill the hole in the screw. You can use a driver to turn this screw, and the tip of it acts like a drill bit, and it'll drill through the material, and then it'll thread its own threads on the way in. To achieve proper holding, it's important to use the proper size bit when drilling the pilot holes for the thread forming screws. The correct drill bit size used for a specific size screw is usually marked on the box containing the screws. Some types of thread forming screws also drill their own holes, eliminating drilling, punching, and aligning parts. Thread forming screws are primarily used to fasten light gauge metal parts together. They're made in the same diameters and lengths as wood screws. All right. So here are a couple examples of those self-threading screws, thread cutting screws. Drywall screws are thin self-drilling screws with bugle-shaped heads. Depending on the type, these screws cut through the wallboard and anchor themselves into wood and or metal studs, holding the wallboard tight to the stud. So drywall screws are very versatile. You can use them for all sorts of things on the job. Here's a coarse thread as opposed to a fine thread. This one says high and low thread. So it's got one thread that's larger and then one that's smaller in between. It's hard to see it from this, but this one is shorter than this one. This one's shorter than this one. Coarse threaded screws are normally used to fasten wall boards to wood studs. Fine thread and high and low thread types are generally used for fastening to metal studs. Some screws are made for use in either wood or metal. A Phillips or Robertson drive head allows the drywall screw to be countersunk without tearing the surface of the wall board. 2.2.7, using drive screws. Drive screws do not require that the hole be tapped. They're installed by hammering the screw into the drilled or punched hole of the proper size. Drive screws are most often used as part that will not be exposed to much pressure. Typical use for drive screws is to attach permanent nameplates on electrical motors and other types of equipment. So they don't hold a lot. You can't use them to hold a box to a wall, but you can use them to hold a little nameplate to a box. They have very shallow threads. You drill a hole and then you just hammer them in and they'll stay there. 2.3.0, hammer-driven pins and studs. Hammer-driven pins and threaded studs can be used to fasten wood or steel to concrete block without the need of pre-drilled holes. To do so, follow these steps. Insert the pin or threaded stud into a hammer-driven tool designed for its use. The pin or stud goes into the tool with the point end out and the washer seated in the recess. Position the pin or stud against the base material where it is to be fastened. Tap the drive rod of the tool lightly until the striker pin contacts the pin or stud. Strike the tool's drive rod using heavy blows with about a 2-pound engineer's hammer. The force of the hammer blows is transmitted through the tool directly to the head of the fastener, causing it to be driven into the concrete or block. So these are those studs that they're talking about. A lot of times you'll use a powder actuated tool to put these in. They're saying you can do it by hand if you use this drive rod. So this center part moves, and you put the stud in one end, and then you put it up against the concrete where you want it. The only problem with that is you have to have everything in place. If you're using it to hold a box, the box has to be there. And if you're using a washer, the washer has to be there. And then you get everything lined up. You have somebody help you. They can hold the box. And then you hammer it right into the concrete. For best results, the drive pin or stud should be embedded a minimum of a ½ inch in hard concrete or 1¼ inch in softer concrete. 2.4.0 Safety requirements for stud type guns. Stud type guns are powered by powder, gas, or spring power. Can drive a wide variety of specially designed pins and threaded stud fasteners into masonry and steel. Powder actuated tools look and fire like a gun and use the force of a detonated gunpowder load to drive the fastener into the material. The load is typically 22 caliber, 25 caliber, or 27 caliber. The depth to which the pin or stud is driven is controlled by the density of the base material in which the pin or stud is being installed, and by the power level or strength of the case powder load. So here's an example of a powder actuated tool. You cock it just like a gun, and here are your charges or your loads. This strip, if it's a strip, it goes up through the bottom, and as you cock it, this will advance one place. So you can fire, and then you cock it, and it moves on to the next one. You fire and cock it, and it moves on to the next one. So it's self-loading. These usually have 10 loads on one strip. Powder loads and their cases are designed for use with specific types and or models of powder actuated tools. They're not interchangeable. Typically, powder loads are made in 12 increasing power or load levels to achieve the proper penetration. The different power levels are identified by a color code system and load case types. Note that different manufacturers may use different color codes to identify load strength. Power level 1 is the lowest power level, while 12 is the highest. Higher numbers, power levels, are used when driving into hard materials or when a deeper penetration is needed. Powder loads are available as single-shot units or for use with single-shot tools. They are also made multiple strip or disc for semi-automatic tools. Warning: only a trained and licensed operator may use powder actuated fastening tools. The operator must strictly follow the tool operator's manual. If you're licensed, you must carry your license with you whenever you are using a powder actuated tool. If you see one of these on the job, don't pick it up. Don't play with it. It's dangerous. They're run by gunpowder. They are like a gun, and they can send a projectile flying. People can get hurt. People can get killed. Don't touch them. You must be trained and certified before you're allowed to use one on the job. If you're found using one and you are not certified, you'll be fired. There may be criminal charges. I'm not kidding. These things are deadly. You need to stay away from them. You may not have to be licensed for some other types of stud guns, but they present very similar hazards and may require special training by your company. So here it says, trained operators must take precautions to protect themselves and others when using a powder actuated driver tool, including the following. Always use the tool according to the published tool operation instructions. Instructions should be kept with the tool. Never attempt to override the safety features of the tool. Never place your hand or other body parts over the front muzzle end of the tool. Use only fasteners, powder loads, and tool parts specifically made for use with the tool. The use of other materials can cause improper and unsafe functioning of the tool. Operators and bystanders must wear eye and hearing protection along with hard hats. Other personal safety gear may be required. Always post warning signs that state powder actuated tool in use within 50 feet of the area where the tools are being used. Before using a tool, make sure it's unloaded and perform a proper function test. Check the functioning of the unloaded tool as described in the published tool operation instructions. Do not guess before fastening into any base material. Always perform a center punch test. Always make a test firing into a suitable base material with the lowest power level recommended for the tool being used. If this does not set the fastener, try the next higher power level. Continue this procedure until the proper fastener penetration is obtained. Always point the tool away from the operator or bystanders. Never use the tool in an explosive or flammable area. Never leave a loaded tool unattended. Do not load a tool until you're prepared to complete the fastening. Should you decide not to make a fastening after the tool has been loaded, always remove the powder load first, then the fastener. Always unload the tool before cleaning or servicing, when changing parts prior to work breaks, and when storing the tool. Always hold the tool perpendicular to the work surface and use the spall, the chip or fragment guard, or a stop spall whenever possible. Always follow the required spacing, edge distance, and base material thickness requirements. Never fire through an existing hole or into a weld area. In the event of a misfire, always hold the tool depressed against the work surface for at least 30 seconds. If the tool still does not fire, follow the published tool instructions. Never carelessly discard or throw unfired powder loads into a trash receptacle. Always store the powdered loads and unloaded tool under lock and key. Here's a case history. I'll let you read it. Masonry anchors. Mechanical anchors are devices used to give fasteners a firm grip in a variety of materials where the fasteners by themselves would otherwise tend to pull out. Anchors can be classified many ways by different manufacturers. In this module, anchors have been divided into 4 broad categories: one-step anchors, bolt anchors, screw anchors, and self-drilling anchors. 2.5.1 One-step anchors. One-step anchors are designed so they can be installed through mounting holes in the component being fastened. This is because the anchor and the drilled hole into which it is installed have the same size diameter. They're available in various diameters and lengths. Common types of one-step anchors include the following. There's a wedge anchor, or a stud anchor, a sleeve anchor, and a one-piece anchor. Like they just said, you drill the same size hole for the anchor, and then you hammer it in. This wedge will spread this collar and make it grip the sides of the hole. This stud anchor will do the same thing. This stud will push up inside, splitting these out. This sleeve anchor is very similar to the wedge anchor in that the bottom is wedge shaped and it will slide into the sleeve. And then a one-piece anchor, as you hammer it in, these bow legs will be bowed out even more and they grip. Here's a screw. We always call these nail anchors because you put it into the hole and then nail this nail into the sleeve, causing the sleeve to expand and grip the sides of the hole. Here's a Sammy anchor. It has a female thread on one side and this male thread that gets threaded into a hole, just like the Tapcons. And then you have the hole that you can put all thread into it, or a bolt, or what have you. Wedge anchors. Wedge anchors are heavy-duty anchors supplied with nuts and washers. The drill bit size used to drill the hole is the same diameter as the anchor. The depth of the hole is not critical as long as the minimum length recommended by the manufacturer is drilled. After the hole is blown clean of dust and other material, the anchor is inserted and driven with a hammer far enough so that at least 6 threads are below the top surface of the component. Then the component is fastened by tightening the anchor nut to expand the anchor and tighten it into the hole. So what they're saying is, as you tighten this nut, you're going to pull some of these threads up through the hole. So you want to have at least 6 threads down, and then as you put the nut on and start tightening it, it'll pull this wedge part up, and it'll anchor that wedge anchor in the hole. Stud bolt anchors are heavy duty threaded anchors. Because this type of anchor is made to bottom in its mounting hole, it's a good choice when jacking or leveling the fastened component is needed. The depth of the hole drilled in the masonry must be specified by the manufacturer to achieve proper expansion. Make sure you don't drill them too deep. If you do that, you're just going to lose the anchor in the wall and have to drill a new hole. Sleeve anchors are multi-purpose anchors. The depth of the hole is not critical as long as the minimum length recommended by the manufacturer is drilled. After the hole is blown clean of dust and other material, the anchor is inserted and tapped until flush with the component. Then the anchor nut or screw is tightened to expand the anchor and tighten it in the hole. One-piece anchors are multi-purpose anchors. They work on the principle that the anchor is driven into the hole. The spring force of the expansion mechanism is compressed and flexes to fit the size of the hole. Once set, it tries to regain its original shape. The hole drilled in the masonry must be at least deeper than the required embedment. Follow the manufacturer's instructions. Here this is highlighted. It says hammer set anchors. Hammer set anchors are made for use in concrete and masonry. There are 2 types, nail and screw. Advantage of the screw type anchor is that they are removable. Both types have a diameter the same size and anchoring of the hole. Both types, the anchor hole must be drilled to the diameter of the anchor and to a depth of at least 1/4 inch deeper than the required for embedment. Follow the manufacturer's instructions. After the hole is blown clean of dust and other material, the anchor is inserted through the mounting holes in the component to be fastened. Then the screws or nails are driven into the anchor body to expand it. It's important to make sure that the head is seated firmly against the component and is of the proper embedment. Hammer set anchors. Did they show us a picture of that? No, I don't see a hammer set anchor. All right. Threaded rod anchors. Threaded rod anchors such as the SAMI anchor are available for installation in concrete, steel, or wood. The anchor is designed to support a threaded rod, which is screwed into the head of the anchor, and the anchor is after the anchor is installed. Special nut drivers available for installing the screws. Bolt anchors. Bolt anchors are designed to be installed flush with the surface of the base material. They're used in conjunction with threaded machine bolt screws. In some types, they can be used with threaded rod. Some commonly used types of bolt anchors include drop-in anchors as well as single and double expansion anchors. So this is what they're talking about. And yes, these will end up to be flush with the material you're anchoring to so that you can bolt something flush to the wall. Here's a standard drop-in anchor. Here's a hollow wall set. Here's expansion anchors, a single wedge and a double wedge. You can see there are wedges at both sides. Drop-in anchors are typically used as heavy-duty anchors. There are 2 types of drop-in anchors. The first type is a standard drop-in anchor made for use in solid concrete and masonry. It has an internally threaded expansion anchor with a pre-assembled internal expander ring plug. The anchor hole must be drilled with specific diameter and depth specified by the manufacturer. After the hole is blown clean of dust and other material, the anchor is inserted and tapped until it's flush with the surface. Following this, a setting tool supplied with the anchor is driven into the anchor to expand it. The component to be fastened is positioned in place and fastened by threading and tightening the correct size machine bolt or screw into the anchor. So the second type is called a hollow wall set. It takes a special adapter to install it. It is made for use in hollow concrete and masonry base materials. Hollow set drop-in anchors have a slotted, tapered expansion sleeve and a serrated expansion cone. They come in various lengths compatible with the outer wall thickness of most hollow base materials. They can also be used in solid concrete and masonry. The anchor hole must be drilled to the specific diameter specified by the manufacturer. When installed in hollow base materials, the hole is drilled into the cell or void. After the hole is blown clean of dust and other material, the anchor is inserted and tapped until it is flush with the surface. Following this, the component to be fastened in position is positioned in place. Then the proper size machine bolt or screw is threaded into the anchor and tightened to expand the anchor into the hole. And they talk about the single and double expansion anchors are both made for use in concrete and other masonry. Double expansion anchors used mainly when fastening into concrete or masonry of questionable strength. For both types, the anchor hole must be drilled to the specific diameter and depth specified by the manufacturer. Screw anchors. Screw anchors are lighter duty anchors made to be installed flush with the surface of the base material. They're used in conjunction with sheet metal, wood, or lag screws, depending on the anchor type. So this is what they're talking about. You've seen these, you've bought things before that came with these little plastic inserts. You drill a hole and you put the insert in the hole and then you can screw into it. It expands as the screw goes in. There you go. Yeah. Fiber and plastic anchors are typically used in concrete and masonry. Plastic anchors are also commonly used in wallboard and similar base materials. The installation of all types is simple. The anchor hole must be drilled to the diameter specified by the manufacturer. Minimum depth of the hole must equal the anchor length. After the hole is blown clean of dust and other material, the anchor is inserted and tapped until it is flush with the surface. Self-drilling anchors. Some anchors made for use in masonry are self-drilling anchors. The one in figure 47 is typical of those in common use. The fastener has a cutting sleeve that is first used as a drill bit and later becomes the expandable fastener itself. A rotary hammer is used to drill the hole in the concrete using the anchor sleeve as the drill bit. Let's take a look. There you go. So here, this is the part they're saying is going to be used as the drill bit. And then once we get the hole drilled, then we're going to put the wedge in and make this part of the anchor. Drilling anchor holes in hardened concrete or masonry. When selecting masonry anchors, regardless of the type, always take into consideration and follow the manufacturer's recommendations pertaining to the hole diameter and depth, the minimum embedment in concrete, the maximum thickness of material to be fastened, and the pull-out and shear load capacities. When installing anchors and/or anchor bolts into hardened concrete, make sure the area where the equipment or component is to be fastened is smooth so that it will have solid footing. Let's see here. Let me look at the drawing. There we go. So step one, you drill the hole to the depth specified by the manufacturer, and you're going through the material to be anchored. You've already got it in place. Then you put this anchor through the hole in the concrete or masonry, and you hit it with a hammer, get it till it's flush. And then as you start tightening it, what's going to happen is these threads are going to pull up on the sleeve, and the sleeve is going to or the wedge is going to cause the sleeve to open and bite the sides of the hole. So they're really good anchors. And the thing is, if you don't succeed the first time, you can remount these. Like if you pulled up on it and you got it too long, the length of the stud showing, you realize that you really didn't get a good grip on it. You can loosen this nut up back to the top, take your hammer and re-hammer it down into the hole. And a lot of times what happens is dust and debris will fall through the sides and get wedged in between the anchor and the side of the hole, so that the second time that you go and tighten the nut, it will then bite. You'll get a good bite on it and you'll get it nice and tight, and everything will be fine. Warning, drilling in concrete generates noise, dust, and flying particles. Always wear safety goggles, ear protectors, and gloves. Make sure other workers in the area are also wearing protective equipment. Follow your company's silica rules to prevent exposure to concrete dust. Okay. And then they tell you what we just did. Drill the anchor hole to the same size as the anchor bolt. Drive the anchor bolt into the hole using a hammer. Put a washer and nut on the bolt and tighten the nut with a wrench until the anchor is secure in the concrete. Hollow wall anchors. When you must attach to hollow materials, use hollow wall anchors. Installations where these anchors would be used include concrete planks, blocks, structural steel, wallboard, or plaster. Common hollow wall anchors include toggle bolts, sleeve type wall anchors, wallboard anchors, or metal drive-in anchors. So installing toggle bolts. This is a toggle bolt. Reason for that is because the head of it will toggle. These will swing down, they're on a spring, and you can swing it down to where this anchor takes up a lot less room. You could fit it through a hole. Once you get it past the end, these two arms will spring back straight, and then as you start tightening, it will back up against the material, usually drywall. Here's a plastic toggle that you can push this almost straight, and then as you get it up through the hole, it will have a tendency to try to come back to a natural position, and then you can put a screw in and catch it on the end here. And as you start tightening it, this is going to come down flat until it's flush against the drywall. So here, round head, flat head, they sometimes call these countersunk. Here's a mushroom head, a button head, or slotted head. This one has a tie wire toggle bolt. You can put tie wire in here. A fixture hanger. It's 11 inches across when it's open. Once the toggle bolt's installed, be careful not to completely unscrew the bolt because the wings will fall off, making the fastener useless. Screw-actuated plastic toggles are also made. These are similar to metal toggle bolts, but they come with a pointed screw and do not require as large a hole. Unlike the metal version, the plastic wings remain in place even if the screw is removed. Toggle bolts are used to fasten parts to hollow block, wallboard, plaster, panel, or tiles. Use the following steps to install a toggle bolt. Select the proper size drill bit. Check the toggle bolt for damage or dirty head. Threads. Drill a hole completely through the surface to which the part is to be fastened. Insert the toggle bolt through the opening into the item being fastened. Screw the toggle wing into the end of the toggle bolt. Fold the wings completely back and push them through the drilled hole until the spring opens. Pull back on the item to be fastened to hold the wings firmly against the inside surface to which the item is being attached, and then tighten the toggle bolt with a screwdriver until it's snug. Think about it. What will happen if you tighten a toggle bolt too tightly? Well, you'll break the drywall. It'll come right through it. Installing sleeve type wall anchors. Basically, the manufacturer is going to tell you what size hole to drill, and then as you put these in and start tightening, this will accordion. It'll fold, it'll shorten up, and it'll make its own kind of a toggle. It'll hold against the back of the drywall. These just get screwed into a hole in the drywall. You make a nice clean hole, you screw these in, and the threads are what hold it in place. Then you can put a smaller threaded screw inside the sleeve. Metal drive-in. I've never used these. I don't know how they work. I have to be honest with you. Looking at the drawing, I'm trying to figure out how they would function. I don't know. I guess you put these through the hole, and then as you put the screw in, it's going to make these lay back on themselves as the screw gets screwed in. I don't know. So installing wallboard anchors, it says drive the anchor into the wall with a Phillips head manual or cordless screwdriver until the head of the anchor is flush with the wall or ceiling surface. Position the component being fastened over the anchor. Secure the component with the proper size sheet metal screw driven into the anchor. Okay. Installing metal driving anchors. Metal driving anchors, like the ones shown in Figure 50, are used to fasten light to medium loads to wallboard. You have two pointed legs that stay together when the anchor is hammered into the wall and spread out against the insides of the wall when the sheet metal screw is driven in. All right. I guess that's what they're talking about. Yeah. All right. Again, I've never used one like that. Epoxy anchoring systems. This is some of the best anchoring systems you can use because once the epoxy is hard, nothing's moving. You can use epoxy resin compounds to anchor threaded rods, dowels, and similar fasteners in solid concrete, hollow wall, and brick. A two-part epoxy is typically packaged in a two-chamber cartridge that keeps the resin and hardener agent or ingredients separated until use. This cartridge is placed into a special tool similar to a caulking gun. When you pump the gun handle, the epoxy resin and hardener component are mixed within the gun. Then the epoxy is ejected from the gun nozzle. So drill a hole in the proper size in the concrete, clean the hole using a nylon brush, dispense a small amount of epoxy from the gun to make sure that the resin and hardener have mixed properly. You can tell because the epoxy will be a single color. Place the gun nozzle into the hole and dispense the epoxy until half of the depth of the hole is filled. Push the selected fastener into the hole with a slow twisting motion to make sure the epoxy fills all voids and crevices. Then is set to the required plumb or level position. After the recommended cure time for the epoxy has elapsed, tighten the fastener nut to secure the component or fixture in place. So don't do anything with the nut until after this is cured for 24 hours. You want it to harden. Procedure for installing a fastener on a hollow wall or brick using epoxy is basically the same as that described for the solid concrete. Here's section 2.0.0 review. It's recommended that zip ties that will be used outdoors. You remember us talking about that? I'm not going to answer these. I'll let you answer them. Which of the following is true regarding screw gauges and shank sizes? When installing hammer-driven pins and studs, when using a powder-actuated tool, the type of fastener that uses the anchor itself to drill as a drill bit is what kind, and a type of fastener with spring-loaded wings and epoxy anchoring systems are commonly used to anchor fasteners in what? Okay. Very good. We'll go on to the next section. I'll see you on the next video.